Hello, thanks for coming out. My name is Matt McKenna. I am an Android GDE currently working at Square, and today we're going to talk about the mental model of offline apps, and I'm going to challenge some understandings of what we have of those. But to get into what we're going to talk about today, we're going to go through what does it mean to be offline, some of the benefits of being offline, how to actually mentally model our offline apps and shift our understanding a little bit, a couple common challenges, and then wrapping it up with the principles of good offline design. And so to start off, let's just start with a standard app flow, and we'll start online. And this is going to be the standard experience. So we usually have a view that connects with a view model, a repository, and a remote data source, and a server. So when the user taps a button, we ingest that from the view. Then we send that event through the view model to the repository, which talks to the data source, and that asks our server for some information. And then after what is hopefully a short amount of time, that server comes back, goes into the reverse cycle, and brings the user up to speed with what they asked for. And so that's all well and good. But what happens when we lose internet connection? And we go from this to not having that connection to the server. And we really need to consider how our apps respond in this scenario, because it breaks for a lot of users. And so to get into what this means, we have to talk about what it means to be offline. And there's a bunch of different types of disconnection. So we could be with temporary disconnects. That's one of this style. It could be on the subway. It could be driving along country roads, or it could be in a congested area like a conference, city, restaurant, stuff like that. And has anyone used the conference Wi-Fi? Had a good experience today? Spending a little, good, bad? That's what we're talking about. Like, we cannot really know. But there's other types as well. So user control disconnects. And this could be airplane mode. Maybe Wi-Fi stays on for this user, maybe it doesn't. Or limited bandwidth network. So maybe this user has like a pay-as-you-go plan, and they want to really restrict what their apps are allowed to do. And a third type is service level disconnects. This could be anything from an ISP outage, where your actual internet provider isn't providing you data, but you still might have Wi-Fi. A service level outage, where you want to interact with a service, but they're not online. Like you click play on Netflix and it doesn't play. Or it just could be as simple as a power outage. You have a bad storm, you lose power, and can't connect. All this to say, networks are unreliable. And we know this, and we do plan for this in most ways. But I want to just ask the question, do we do that in the best way? And my argument is no, because we get hit with a lot of these things where it's like, we first of all blame the user and say, hey, you're offline. Like, this is your fault. Or we just tell them to try again. And having something that is just this non-responsive button that's try again, it's not a very satisfying experience. That user is going to leave our app, do something else. And they deserve better. So what if, despite network conditions, our users could interact with most of the functionality of our apps? And so that brings us to this new mental model of an offline app. And I want to introduce you to what I think is a great way to think about how an app can work while offline. And to do that, this is where I'm going to challenge some understandings. Online is offline. What? It sounds a little counterintuitive, but I'm going to convince you that it is. And it all comes down to latency. And just like earlier, where we talked about a bunch of different types of disconnection, they all provide different types of latency. And we really need to move away from this binary understanding of online and offline. And so if we consider latency as a spectrum, we can start thinking of online and offline being synonymous. And so in an online scenario, latency is low. We typically have under a 1-second response time, and users typically don't notice anything. But then if we get into our temporary disconnects, this could be that subway situation. You could be offline for a minute to an hour. User level disconnect, this could really be anything. I tried to model something here, but who knows how long users have their devices offline. This could be something like a long flight where they go into airplane mode and are disconnected, or it could be maybe a restricted device for children that they don't want to have access to the internet. We really have no idea. And back to that service level disconnect, this could be anything from an hour to days based on weather conditions, or if there is an actual outage of a service provider. And so how do we approach supporting this? I really want to drive home that considering online and offline like this, it puts online in the same spectrum as this offline scenario. This is like the mental model shift. And it is technically as inconsistent as the others. We don't know once we send a request that it's going to come back to us. We just kind of trust that the server is going to be there. And so we come up with strategies to handle this. And one of those is the empty states, and we saw that, and it's not necessarily ideal, but maybe it does make sense sometimes. And something where it would make sense is maybe like a live streaming app or other apps that require active network, like rideshare or something like that. We could have split functionality. This is adhering a bit more to that binary online-offline approach, but it can make sense for some apps, and the key there is probably media streaming apps, where you do download a movie before your flight, you do download a podcast, and then you have that on your device, and it doesn't matter what your connection is anymore. And then we can go offline first. And this is what we're going to focus on today. I feel like this is a very good generalistic approach to building an offline supported application. And offline first. So yeah, what's that mean? It basically just means local first. And I want to switch to saying local first because we've already seen that online and offline, if we're calling them the same thing, we need different phrasing for what this is to avoid some confusion. This is really helpful when talking with people like your product managers and designers, where it's like how they will hold on to this offline keyword way too long and want to say the app is online, why can't I do this? And it's really important to say yeah, we do things locally first. It's just a much clearer way to talk about something. But yeah, so it's basically prioritizing the local storage. We write to storage, we do things on the device first, and then later, when we have a network connection, is when we process those changes. And so the user isn't blocked waiting for something to happen. And then it comes when we have network, there's going to be a mechanism that handles this for us. And the goal is to really just provide a really seamless experience for the user. They really shouldn't have to worry about what their network state is. They just want to use the app, use our products, and get in, do what they want to do. It's really the ultimate goal is to not even have them know that they are online or offline. And yeah, so from the user perspective, their app always works. But then the other big benefit is debugging. And so from our perspective, we don't have to worry about two paths. We don't have to consider, okay, are we offline? We have a bug. We need to first figure out, was the user online? Were they offline? Were they in airplane mode? Did they have Wi-Fi? Did the server fail? We know that they've written something to disk. They know that we've done this on their device, and then from there, it's one path. We can follow the same path every time, and it's a much easier debugging experience. And so you don't have to do double the work. You don't have to do all the extra consideration. So a local first app, what does that look like? We can go back to our online-only app, and we'll move the remote stuff over to the side real quick, and we'll add this local data source. And we'll create this sync component that talks to, which talks to the remote and brings it all the way back to local. But really, just to focus on this part, this is a functioning app. From the user's perspective, they can do everything that they want to do. without any of this network stuff. They could turn off their device. They could, like network connection, doesn't matter. They'll be able to do what they want, and we just don't block them. And for you, it just works for them. But then there's this sync component, and this is really the crux of what it means to support this local first application, because this is what's going to carry all the data from our apps to the server through this remote data source. So if we remove all the UI, we have this sort of loop, and the UI can be changed, filtered out, it doesn't matter. But this sync component has a bunch of core responsibilities that it needs to be able to handle. And it's pretty straightforward. It needs to observe for data changes, whether it does that by just watching the local storage, or if it does that by user interaction. It doesn't matter. It's really up to how you want to implement your app. It needs to observe for the network changes. This is the key component where we want to do the work when we can, and we want to basically silently retry if we don't have network, or if the call fails because of service outage or whatever. Like, the user doesn't need to know. They can rely on us to have this component to do this for them. And then it really needs to coordinate syncing the data. And this could be done in a couple ways. Like, it could be done on an interval. It could be done based on interaction. It could be a mix of the two. It could observe both the networks and fire all the time. Or it could be manual. Users could initiate a manual backup, and that would handle syncing and persisting their data or whatever other interactions your app supports elsewhere. And so we don't really add too many components. We just need to store the local changes and mutations to our data, and then have the component to handle basically watching the network for us and getting that up to speed. But arrows go both ways from the sync component, because it really needs to handle the push from an app and the pull from the server, because clients or apps can have multiple devices, and if a user has a tablet and a phone, they're going to want to see their data on both, not just one. So that brings us to some of the common challenges. And we recently did a lot of this at work, and these are the two that we dealt with that were really caught us by surprise. And so the first of these is the 2ID problem. And so when we have an object that we are dealing with locally, that object usually has an ID, and this ID is responsible for communicating about this object and with the server, and then all of the other relationships with this object and other objects. And so a lot is handled by an ID. And that's OK. If the app and the server both point to the same ID, we have no problems. But this is really like an online first thinking, where the app asks the server to create and mutate things for the app, because then the server is doing all of the work in generating this ID and giving it to the devices to use. But in an offline world, this kind of breaks, because the device could be offline, not talking to the server, and therefore not having this ID that we're asking the server to create. Or we do create this ID, and then the server has to respect it too, but it might need to know some information about these IDs in general. And so the obvious answer is to just have two IDs. We have one on the app side and one on the server side, and that's all you really need to know. This is like a simple answer to a complex problem and doesn't solve everything, because now you have to worry about those relationships again. And so how does the server handle the relationships between these IDs? How does the local ID handle the relationship on the client between these IDs? And it gets even more complicated when maybe you add a web interface, which does talk to the server and ask the server to create only server IDs for this object. And maybe you have an API that allows people to interact with and do the same thing. And so you end up in a situation where sometimes you'll have one ID, sometimes you'll have both, sometimes you'll have only local, only server. And what should we do? There are a couple solutions. They can change depending on what your app supports and what you want to do and where you are in terms of this implementation. But one of the easy answers is to keep a map of the local ID to the server ID. This can be done on the app side, and then when you go to interact with things on the server, you either don't have the ID yet because you haven't created on the server, or you just use the server ID that's stored in this object or just in this map. And it is another thing to maintain, but it's not super impactful and terrible. It can be a little bit of a performance impact to update this, especially if you're already existing in a world with a bunch of server IDs and you need to backfill things. And so we could backfill this missing ID, but then you also have to worry about knowing which ID you're missing. And it could be either ID, because you could be creating one on the app side, you could be creating one on the server side. And this could be a good solution for you, but it's definitely one of the most challenging ones. Or we could just always use the local ID if it exists. So on our app side, if we have the local ID, we can use that. If we have the server ID, we can use that. We will typically always have one. It would be very weird if you got into a situation without one of these, especially when you're creating these objects with the purpose of having them. But the key thing there is you only use the local ID on the client to manage those relationships, and then when interacting with the server, that sync component is going to use the server ID to keep things up to date. So then, yeah, the next big thing is going to be conflict resolution. So if you have offline support in your apps, you could have multiple clients that are going to interact with the same object with the same ID at the same time, and you are going to need to figure out which changes are going to stick around when they both make it to the server. And this is also super dependent on what your app supports. I think a good case to think about this is messaging apps, where things usually have a timestamp. That timestamp can either be like when the user tried to send it or when it actually got sent. And so what order in the list is this message going to show up? And some solutions really just choose the best effort for your app. Common solutions are either first or last write wins. So you could have a combination of these. Like sometimes maybe you are done with an object, and say in a project managing app, you mark a ticket as done and then don't allow any more changes to it. Like that could be a first write wins. It gets marked done, and you're just, that object doesn't accept any more changes. Or it could be a last write wins, where whoever writes to that object latest means that that's the state that we're going to see things in. It could be a client/server wins. We could just say the server's always right. So if the server was updated elsewhere, that's the data that we're going to go with, and then we'll just overwrite the local client. Or we could try to do some best effort merge. And this, I call it best effort merge, and this is kind of the one that we aren't going to really surface to users. But we could also do a manual merge, where users do have some say in what sticks around in an object. I would say these two are probably the most challenging and really depend on what your data looks like and what your app is supposed to be responsible for. So that just brings us to some principles of good offline design. And to start this off, you got to start somewhere. And what I mean by this is not in the implementation, but with the actual data. So if you have a returning user, they could have some to-dos on their to-do list or something else that already exist, and maybe they got a new device and they open your app, and how do they get all of their existing data to their device? So you need to have some mechanism to bring that data to them. And then you can start with that whole offline first approach and syncing and whatnot. But this is typically going to be like an online operation where you get a user off the ground up to where they were. But it does primarily end up benefiting your returning users, because once they have this done, they will be able to do things offline first and really just continue with their consistent experience. Second, don't start if you can't finish, and again, not about the implementation. This is one of those things where if you do have an online flow and you don't have a mechanism to save that data or queue that data for later, you should let that user know that they can't complete the task or should be wary about giving time to completing this task, because there's nothing worse than getting to the end of a long flow and saying, we can't save this. So just be wary about what that means, and maybe limit some of the functionality of your apps if you know you don't have a good connection. And part of that is to communicate with care. And this could be a lot of things where the users need to know what's available or what's working and what's not. And so this could be in a messaging app where you hit send but you don't have a network, and there's a little spinner that's saying like, okay, we're gonna try this later. Or maybe it does fail because it timed out or something, and you surface on that message that there was a failure and they can retry later. But really, the key thing here is don't make it the user's fault. We are the ones who are responsible for providing a good experience for them. We don't want to blame them for things not working, especially when they're just trying to use our products. And so I talked about this a little bit, but handle errors gracefully. Errors are not really retryable. They shouldn't need to be retried by the user in most situations. And with this offline first approach, errors are going to be asynchronous. So we don't know when the user is going to have a network again to get this error. And that's why we need to have some way to surface this to them. But errors were actually always async. We just kind of blocked the user on that experience before in our online world. We waited for the server to respond and then surfaced something like this. So it's really just a better system overall. So yeah, final piece, we want to synchronize that data. We want to really make sure that we have a strong component there that's going to do the work for these users. And this is what's really going to enable them to interact with everything. So again, the primary goal of a local first app is to not have the user really know that they have any sort of network state or problems. And maybe they intentionally disconnect, maybe they don't. There's nothing more frustrating than trying to update or do something and just be told that it's not going to work, or even worse, waiting the entire call timeout period just to see, like, users just don't stick around that long. So that's pretty much it. So yeah, thanks for coming. I'll stick around for questions. So yeah, let me know.